Thanks for joining again for another edition of On Point Podcast, where we bring industry leaders and influential people, scientists, artists, and people that made and shaped the glass industry. And today I'm really pleased to be joined by Bruce Nicol, who's been in the industry what seems like forever and has shaped everything from technology-driven glass, solar, to working with iRise, and I'm sure worked on many BAFTA award-winning projects. Bruce, welcome today.
Thanks, Rod. Always a pleasure. And yeah, it seems like yesterday that I crossed the line from being an architect to going in the glass industry.
Yeah.
Thought I'd only be there for 2 years, lift some glass, learn how the material's made, but you know, you think you get out and they pull you back in.
Well, I'm trying to think when we first met. He was in Steyr, I think.
It was, yeah. We were doing some projects, ordering some glass, and we came and had a beer or two in Stadtplatz.
Yeah. No, great place. But I think that's when because it's not just architecture, you're into your engineering as well.
Yeah.
And how that gets together. And it's probably where I got first excited, because we were working, I think, on a bolted glass thing, which we came over, and I could see you picked it up straight away. And I was learning, I was just seeing your process and all the things that, I hadn't come across at the time, different laminates, different temperatures, and you were showing me around. So yeah, thanks for that, because I probably never thanked you at the time. I probably came in thinking, I need to be clever and know what I'm doing. And
Yeah. Well, one thing I've learnt is we're still learning. Nobody's that clever, they know everything.
Yeah.
Because we know from glass that we only know 50% of what it can do.
Yeah.
So this is what keeps the interest going.
So what you been up to? So I know you've recently joined. You've gone back to Steyr.
Circular life kind of thing. So as you mentioned, we met in Steyr many years ago. I'd been an architect, or still am an architect, working in glass in London. Got invited by Eckelt to go to the factory, so I went initially for 2 years, and we made projects everywhere and worked with great architects. So I just got this passion and stayed. My private life took me back to UK. I joined Arup in the facade team there, which I thought would be my spiritual home.
Right.
But I think I'd just been on the road too long, and I was a bit got itchy feet when I was sort of grounded going to the office every day.
Okay.
So I joined Dow to learn about silicon, which is neat, and then I got a chance to join iRise, who were actually not iRise then, but they're a Merck company, who are a German pharmaceutical company, who took one of their inventions, which is liquid crystal, that they invented in 1904, into glass technologies to make a dynamic glass. So I was involved with them for 6 years, changing or helping them develop a market and raising the visibility of a glass which could change very quickly and change light transmission and GVAR. Went back into consultancy. I live in Berlin, so I joined a company called Priedemann for a year just to see if it would fit. And Eckelt got bought by new owners and called me and said, hey, all those great jobs we used to do, do you want to come back and help us maybe? That's my interpretation. I'm sure they just needed somebody else to join the sales team.
We're getting to a certain age, and it's almost like we've become elders, feeding back into a system.
I mean, it's a great community that we're part of, yourself included.
Yeah.
People want to share the knowledge and want to share their experiences, because as I say, we're still learning about this amazing material. A material has been made for maybe 10,000 years. And we still don't know half of it. I always thought, I still think the Arup team was like being in a university, very open. People connected to the real true greats, or people I looked up to when I was studying architecture. And it's, just great to be part of that community.
So, architect, engineer, glass. I mean, one of the, as an installer, and now, what we do, glass replacements and, the whole facade management and inspection stuff. What do you think about glass getting bigger and bigger, and is it a challenge, do you think? How much bigger can it go? Should it get any bigger? Should we be allowing, the CDAC, 15 metre panels?
It's a neat question. I think There is a discussion, should you just because you can? But I always look in the past to learn about the future. So if somebody asks me what's the longest piece of glass you can get, I say it's 3.2 metres, 3.21 wide, the width of a float tank, 15 years long. Because that's how long a float tank will run for. Right. And the ribbon of glass is moving all that time. So if you can process it or handle it, you could get a piece of glass as long as you want. You know, when we get into those supersized units, 20 metres, I think 22 metres is maybe the longest one I've come across, tempered IGU. Obviously it adds on a lot of logistic problems, not just the initial processing, the future problems. As you're doing glass aftercare, what do you do if you need to replace that unit? Yeah. How accessible is it? You know, the piece of glass might cost X, but replacing it might cost 3 times X. Yeah. It's great to see those big bits of glass. I get really excited. Yeah. Whether there's a place for it in what we're talking about now in trying to save energy. I mean, really there's 2 places in the world you can make those massive bits of glass, 18, 20 metres. And you mentioned Sedoc, the other one's North Glass. Both qualities very good. But, you know, one's in China and one's in South Germany. Yeah. We should think about where we're shipping materials and why.
What do you really think about sustainability? I know some of our colleagues, the family that we talk about, are heavily into recycling the glass, and there's a lot of engineers and engineering houses that are always thinking about how we can, you know, energy save, carbon save the planet. What do you think?
One of the major issues is what we use to reach the temperature we need to melt the stones. You know, we're making transparent stone. Yeah. And to get there, you need 1,500 degrees. And they knew this also in Mesopotamia, way back. But you still need that temperature. And today, maybe there's 500 float lines in the world. When I started, there was 200. Most are in the eastern part of the world. They burn fossil fuels, mainly gas, every day for 15 years. That's a big challenge.
What's the latest thing that's piquing your interest at the moment? You know, you've got...
Yeah. I'm still very interested in the whole dynamic glass world. You know, unfortunately, Irise died, Halio died, View died. So it leaves only Sage. So there are 4 main players in the dynamic glass world. And Sage started it, Sangaban. And I take my hat off them because they've stayed and they've proved they got a system. They had some issues.
Was that a Privolite, wasn't it?
Well, there was Privolite, which was a liquid crystal, but Sage was electrochromic. Right. And it changed very slowly and it was very blue. But I've just been reading that they've got one that's neutral now. Okay. And I'm dying to see it. The switching speed is one thing, but it's not so critical. The range of performance is very good with electrochromic. And if Sage have got this neutral type product now, I think this is really interesting. London's still a great innovator. Yeah. They're a little bit risk averse in London. So all the great innovation tends to actually get built somewhere else and then it comes back to people. There's still a statistic which says 20% of all projects start in London. Talking to people here in the city about new projects, there's a little bit of reaction to closed cavities. You know, closed cavities came out of a whole idea of developing a facade design. You know, the holy grail of glass design, high light transmission, low G values, and how you deal with it, how you make it happen. And closed cavities sort of were trying to do that, but obviously you've got blinds, you've got motors and things, and space, which is a premium. And talking to people recently about saving the space, and we're working together with a company called Microshade, who are Danish, who've got a very fine titanium covered, almost textile type product which goes on the inner surface of the outer glass, so cavity facing, and it provides excellent light transmission, 68%.
So phase 3 or something like that?
It depends. If it's a monolithic, it's set phase 2. Right. Okay. And it's not a laminate, it's basically applied on the glass. And then you use low E coating for thermals. But you get performance range twice that of a high-performance coating. So you get 68% 0.1
Right.
G value, whereas in a coating
Wow.
you might get sort of half that in both ranges.
Yeah.
It's transparent, colour rendering is good. When you get close, yes, you can see something. So from a design point of view, maybe it's not ideal, but it's actually serving a couple of really important points. It's allowing transparency, allowing through vision, and saving space, and being passive.
Yeah.
So I'm saying all the smart technology, maybe it's getting a little bit too smart for its own good, and it can obviously be unsmart in the future.
So to me, smart, going back to what we're working on with the FIMS. So FIMS is really about facade information, and the glass industry's been putting barcodes but the biggest challenge we have is we have a stock of buildings, great quality buildings, with a lack of O&Ms of any quality, and there's no accountability, no nothing. You know, there's talk of golden thread and the whole let's not have Grenfell happen again. The sharing of information about where the glass source came from, how it could be replaced, how it was originally designed, the silicons, the life, you know.
Information sharing and collecting, it's always been part of the business. Whether we've sat down and had a beer in Stein and shared stories,
Yeah.
it's information sharing. And the more information we can share between us, the better we can design and reuse existing facades or not. So at the moment, you know, we have a warranty of 10 years, let's say. The warranty is finished. We say we have a design life of 25 years. But now we're getting real data which showing the design life, the real life is better and longer. You know, what might we be able to use that to give the consultants a little bit more data, so their calculation for embodied carbon could be expanded because we know the design life is longer.
Yeah.
You know, and the more studies are done and the more that knowledge is shared, the better the glass industry would be to open up a little bit in terms of.
Who do you think should lead that? Do you think it should be a government-led thing, or do you think it should be an industry-led thing? You know,
in my experience, let's say the industry will do what the industry does because we've got to make some money. So unless we're told to do something different, it's quite difficult for the industry to be the driver. If you work for a good processor like Eckelt, we're very proactive. So if somebody's coming along with an idea, we want to jump on it. We want to try to make it happen. But there's not really a commercial reason to do it. It might become one. But really, it ought to be driven probably by the government in the end. But some developers here are very, very well integrated with the glass industry. I'm thinking of some of the developers and the work that Saint-Gobain have done in terms of reusing glass. So, and then you've got the consultants in the middle. So the consultant's going to write the spec.
yeah,
In the end, it's a collaboration. But the people who are paying the bills, the developers, have at the moment the chance to drive that direction. And some people are picking up on it. Saint-Gobain have picked on it quite early. The other glass makers are catching up. And us as a proactive processor, we also want to join that sort of that way of thinking because it suits what we think about as well for saving the world. But at the end of the day, legislation will drive everything. But it takes so long to get there. We may have moved on by the time we got there, or we may have destroyed ourselves.
Yeah, I was going to say, well, we seem to have this sort of 2030, you know, which feels like it's forever, but it's only like 5 years away.
Yeah,
So.
we shouldn't wait for legislation because it may never happen, and it's designed by committee. So the solution, unfortunately, is probably going to be half of what it should be. But the developers and the industry, we can collaborate. Yeah, one thing I learned when I was at Arup was really a strength of collaboration. In fact, one of the projects I worked on first round at Eckelt was Prada with Herzog de Meuron.
Right.
Without the collaboration together with first a really good architect who understood the material, we worked with our competitor. We had to, because there's no way to make those bits of glass without somebody with the expertise which they needed. And at the time was Precursor, who could make the form glass that was needed for that project. But they couldn't do what was needed to make a structured piece of glass. So through a collaboration, we made one of the best projects I've been involved in. And I still see it referenced when I'm in conferences, because it's a beautiful piece of architecture. And we shouldn't really ignore that what we're trying to do to save the planet and make everything smart comes back to architecture. If we, and architecture drives the way we live and feel and our well-being. If we built square boxes with no windows and filled it with LCDs, we'd all be dead. Architecture is the driver. So maybe the architects ought to pick it up. But I'd say the design team, the consultants who are part of the team with the developer, they're the drivers at the moment.
Yeah. I think you're actually, when you think about the architects, they have to go, planners, and they're working hand in glove with planners, and planners are given the approvals, and, the amount of information that gets put in to a planning portal that never ever sees the light of day after the event. And I'm just thinking maybe when it's completed, it should be the same amount of inference and demand. Say, okay, well now you've built it, I want to see all the construction drawings, and these can be shared. Obviously on some password basis and things like that on a need to who needs it. But I think that could be a way forward.
Yeah, there was a strong emphasis on BIM modelling. I guess it's still around, but you don't hear that much about it these days. But it was a great way to collect information and hand over a model that basically showed you what everything was and who supplied it. But collecting data of how Windows performing.
Well, even just
very interesting.
Colour rendition. I mean, that's one of the biggest challenges that I'm seeing is obviously low iron today versus low iron even 2 years ago or 3 years ago. Everything's getting clearer. So when you put in different coatings on it, it would just look different. And especially going back now 30 years, where low iron wasn't so much a thing, but the different coatings trying to match people are there's a sacrifice between U values and G values versus how it looks, because otherwise you're going to have that patchwork.
And it's virtually impossible to get a true colour match. As I said, on one job we made that was made over a 6 month period, we took glass from the same furnace, same thickness, and it was a different colour.
Well, I don't know if you're up on the different, how it's all changing, the different codes and standards, and does it have to be laminate? On public buildings, does it have to be laminate inside, laminate outside? There's different implications of that, weights and things like that. Do you have a view on that?
For a very strong view. We need to design glass facades and structures that when they break, they stay in place and they don't fall out. So design for post-breakage behaviour is the key for everything. And if that means it's got to be laminated, then so be it. I quite like designing with annealed laminates, because annealed glass is very flat. The first one I was involved in was Wilkinson Ayres Aldgate Tower. Sheldon made the facade, and Arup, I was in the Arup facade team then. We were able to design a laminated annealed glass. I think it's one of the first main facades where that was used. And it's still beautiful, very flat, reflections are good. I like that as a principle. Obviously, then, like all these things, there's, as I said, pros and cons. So you have to deal with thermal shock. You need a thermal stress analysis at some point. It's not going to work for lots of facades that have shading on facades. But anyway, this is one way to think about it. Laminates allow glass to be safe in place and ought to stay in place in future. If a piece of anneal laminate breaks, it's just breaking with a crack or two. Tougher laminate will expand and bulge and may force its way off a fitting or a frame.
Is there much change? Obviously, you've come back, several years later, and do you see a new improved processing?
No. I see there's companies like Vanderglass who took over Eckelt who've made a really significant investment. So our line is probably the best in Europe, if not the world at the moment. We got a brand new toughening furnace, and last year we invited 12 other specification writers in London to come and play with it. So the line was closed for two hours, right. And our production manager made some strange bits of glass and different thicknesses, ran it through the machine. We showed how the machine was measuring it. We got the guys and girls who came to measure it, because they're the people specifying. And it was really interesting. I don't know anybody in the world who's closed down the line for 2 hours to let a bunch of engineering geeks play and destroy their machine that they just installed. But it was really interesting, and the people who came gave really good feedback, really good discussion with our production manager. And usually these people just go for project-specific glass inspections. Right. And this time, I mean, apart from playing with the toughening machine, we got them to paint bits of glass with ceramic paint. We got them make some IGUs, right, and put the spacer bar where they specify it should be. And the number of fingerprints on the coating from these people, because putting the spacer bar with a plus minus 1 millimetre variation onto the deleted coating, it's not that easy. Yeah,
so they've got a real appreciation of
absolutely,
everything that goes into that.
So I think the technology is the same. The measuring on the lines is much better. But our production guys would probably say the manual, we still do both, because the manual inspection has some variations, and sometimes it's better than what we're seeing with iLook and things like this.
Who's buying where's all the, is it places like Saudi that are buying all the techie glass at the moment?
No, I don't think so.
Where in the world do you think it's?
I think there's a trend. I think there's a lot of, given what's going on with mega projects in Saudi Arabia, there's a lot of push for some different type of technology, or old technology used in a different way, like dichromic glass. Got asked about that for a stadium. Dynamic glass, I think it's maybe not really suitable for Saudi Arabia.
Photovoltaics? Clear?
Photovoltaics, yes, but it's it's in the desert, or a desert climate. It's quite aggressive and got lots of sun, so you need to clean it. So the energy you're producing in a country where energy is cheap, you're just using it to clean the glass. It's a bit. That's why there's really not that much photovoltaic usage in that part of the world. And dynamic facade systems like moving louvers get blocked by the dust. So there's a will, but also these cultures tend to be also quite economically driven. So, and I have to say some of the specifications are not kept. So you get really good specs from this part of the world. And local people, local markets change it, and they're allowed to change it. So it becomes cheap to lose the technology. So,
okay, so Europe's still leading over America then? Yeah.
So Americans still suffer from historical use of smaller bits of glass, which is one of the reasons why we were allowed to step into the US. We did lots of projects in US, including the 18-metre fins in Times Square ticket booth, all glass structure, beautiful, engineered by Anthony Smith, for instance.
If you wanted to be controversial,
not been controversial enough.
If you wanted to be controversial over the next 5 years, what do you think we're going to see that we can't see coming at us, like the general public? And is there something that you can see in the background that's, like
glass-wise?
Yeah. Or even from an architecture point of view, because I know you still keep your finger on the pulse there.
Yeah. I'd like to think that glass is still the forefront of what we do and what we're about as a society in general, and not just the design world. I really think it's a material that saves energy at the end of the day, despite the energy that goes in there to produce it. and the right people, the right designs in the right teams, and it's a collaboration will make this happen. There's not enough collaboration. There's too many people closing the books when we should be opening the books. The glass industry has been described by some as the least transparent industry in the world. Joking aside, it should also open up. There should be more discussions about the lower carbon glass. I think David Entwistle in the presentation called it lower carbon rightly, because actually it is lower in the amount of carbon that's producing it, but there's a long way to go before it's truly low carbon. And the investment on float line, last time I went to one, was over 100 million to build a float line. Wow. There's not many people able to do that these days, so there should be more collaboration. I remember when I was at Saint-Gobain, going to Saint-Gobain line and being stopped as a Saint-Gobain employee, taking a picture of the weir with the glasses flowing out of the furnace into the float tank. Next week, when I'm at Arup, I go to Guardian, and Guardian's like, yeah, come on, get closer. You get closer you want, take some photographs. And I haven't got 100 million to build a float line, so what am I going to do with this information? But, there should be more sharing of ideas. I think there's a real business model to take this glass from this facade, an IGU, standard IGU, strip the whole thing down and reuse everything. Today it's relatively difficult. I think the model from the main glass makers is take that unit, smash the bit in the middle, use that glass, and the rest, unfortunately, still goes to landfill. I know there's people that add up, like Graham de Brincap, for instance, looking at how to really make a business model out of it. At the moment, it's too expensive, but it'll get there. It has to get there.
Yeah. Absolutely.
So I think how we reuse glass and this idea of having more information from existing buildings coming back into the whole design team, sharing that information from Swiss Re, for instance, and every other building that's being looked at the moment. Because, reusing facades, it's a theme that's, in UK, it's very strong and really interesting. In Europe, not so much. Okay. Because the European market is not as dynamic as London, even though Frankfurt would like to be the European capital for finance. 2,000 years of history, it's not going to change. It's here for a reason. And the people here, I think, still have a conscience. They still want to save the planet. And things are happening here faster than they are in Europe.
So if you had to pick one building in London and you were going to give it an award, which one would it be? Old or new?
I really like the Gherkin.
Yeah.
Whatever we want to call it, Swiss Re, St. Mariacs.
Yeah. Because
I think it was the first building that got called an iconic piece of architecture. Yeah. And I think, unfortunately, it sort of spawned the term star architect as well. However, it was, and still is, quite beautiful, doing what it does.
The way it breathes, the whole, movement around the building.
It became a symbol of the city. The regrets that it's been overshadowed by its neighbours. That's also development of the city, really. I guess that's quite an easy one in London.
Yeah.
And we made all the glass, which is great, apart from put on top.
Yeah. Well, Bruce, thank you. We've had a little trip down memory lane and got your input on that. And
always a pleasure.
And it's been good. You're calling out for transparency in the glass industry, and you've brought some clarity, pardon the pun, which was intended. Lovely to see you again.
You too.
Look forward to it. And for hopefully anyone who's listening, you've enjoyed it. Stay on point.
Great. Thanks.
Thanks, mate.